graph this function in our calculators, oops. So x squared plus 2x minus 5, maybe, minus 5. So now we want to look at the domain and the range. Domain is x's, range is y. So I'm going to graph this over here. So it touches somewhere between -2 and -3, and then up here between 1 or so. So we want to know, are there any x values that do not touch this graph? So this is my x-axis. Does x equals 5 touch the graph? Yes. There is a point on the graph that's 5 comma something. So it's all the way up here. 5 comma, I don't know, 9. So we can test all of the x values by imagining a vertical line that touches the x-axis and sliding it back and forth. Does that line touch the graph in its current position? Well, not where it is, but if you imagine the graph continuing on, eventually it's going to touch. Can you find any place on the x-axis that is not going to touch the graph? No. It touches everywhere. So the domain is x equals all of the real numbers. Every single x value appears on that graph. So you can think of it another way. You can think of it as a point on the graph. So this point is 2 comma 0. This point, well, 1.5 comma 0. This point is 2 comma 0. If I move it up, 3 comma, I'm saying one thing and meaning another. 2 comma 2, that would be 3 comma 4. So if I move that point around, is there any x that doesn't appear? They're all there. Every single x. What about my y-axis? If I run a line through my y-axis, are there y values that do not touch the graph? Yes. What is the smallest y value that touches the graph? -6. Okay. The lowest value in this graph is -6. How high does the graph go? All the way up to infinity. So the range is y equals the interval -6 comma infinity. Is -6 part of the answer? So do we use a bracket or a parenthesis? Bracket. And infinity always gets a parenthesis. Does anybody not understand how we got the domain and range of that? You're you're going to be a little behind. Hopefully we'll have time today. I can help you out. All right. So now we need to find the x-intercepts and the y-intercepts. The y-intercept is always the easiest. All you have to do is plug in 0. So you can either plug that straight into the function. If you look at the function, if we plug in 0, that becomes 0, that becomes 0. Nathan and Landon, I want to hear. Is it interesting? Oh, okay. All right, sorry. So the y-intercept is going to be -5. You can do this using your calculator by doing second calc and going to value and plugging in 0, and it will give me -5. If it's a polynomial, all you have to do is read off the constant. If it's not a polynomial, it can be a little bit more difficult, depending. All right. So the x-intercepts are harder. The x-intercepts are the places the graph crosses the x-axis, and they have other names. They're also called roots and zeros. You will hear me say roots most often. The calculator uses the word 0. but they all mean the same thing. Eventually, we'll stop calling them x-intercepts. We just don't use that term. So to do that, you look at the graph, and if it hits on a whole number, you can just read off the number from the graph. But in this case, it's not that easy. So we push second, calc. We go to number 2, which is finding the zeros. And then we have to pick an interval for the calculator to look for the value. So you want to kind of trap in that value on the left side and on the right side. So what would be a good left bound for one of those? Well, let's pick the one on the left. What's a good left bound for the one on the left? -7 would work. A little bit of an overkill. And sometimes if your interval is too big, it'll mess the decimal up by a little bit. Like if it's supposed to be 2 and you pick this really wide interval, then it might say something like 1.9999962 when the actual answer is 2. So sometimes it's good to get close to the root, but sometimes it doesn't matter. All right, what would be a good right bound? -3 would work. It's awfully close to the answer. We could try it, -3. What would be a good guess? -4, somewhere in there. And it says that my root, or my 0, is -3.44, or 45. So if I do the other side, go to 0. What would be a good left bound for the other side? What's that? Yeah, you need to find all the roots. Yep. Yeah, you need to find all of them. But hopefully if it crosses 10 times, it hits at really nice numbers, so you can just read them off. So left bound, I'm going to pick 0. Right bound, I'm going to pick 3. For my guess, I'm going to pick 2. So the other 0 is 1.449. Okay. The decimals match. If the function is made up of the coefficients are whole numbers, that will happen a lot. It's not necessarily a guarantee, but it will happen quite a bit. So he means they were both 0.449, and you will see that a lot, but if it's next to the third graph, you won't. So it can happen if it's a quadratic and the coefficients are all whole numbers. All right, so we're going to move on to this worksheet. So everybody have one of these? Okay. Okay, looking at number 1, this is the same function we dealt with yesterday, 4x minus 32. Yesterday we looked at the x-intercept and the y-intercepts. Today we're going to be looking at positive values and negative values. So it wants to know what values of x make the function positive and what values of x make the function negative. What does it mean for a function to be positive? Well, close. Tomorrow we're going to talk about increasing and decreasing. So on your graph, this is the x-axis, and this is the y-axis, also known as the function axis. So we're looking for the positive y values. So when I plug in an x, when is the answer that comes out positive? Meaning, when is the graph above the x-axis? What interval of x will give me a positive value? Well, what happens at 8? At 8, the answer is 0. Is 0 positive or negative? Neither. So 0 doesn't count. Okay? What happens if I plug in 2? Do I get a positive number or a negative number? If I plug in 2, I get this value down here that's negative. What if I plug in negative 6? I'm going to get a negative that's way down at the bottom somewhere. Okay? And when I hit 8, so if I keep plugging in values, as soon as I hit 8, I stop being negative. So this portion of the graph is negative. So I now need to write the interval of x's that will create negative values on the graph. So negative values come when x equals what? What x's create negative numbers? 7 does, 6 does, 5 does, 4, 3, 2, and 1. Where does that stop? At negative infinity. So at negative infinity is the low end, and I never include negative infinity. It's impossible. What's the high end? Does 8 count? Does 7 count? Yes. 7.5, 7.9, 7.99. Yeah, everything except the number 8. So let me show you again what this means. If I pick any x in this group and plug that x into the equation, the answer I get out will be a negative number. That's what we're doing today. What values for x make the function negative? What values for x land on the graph below the x-axis? All right? When is the graph positive? Eight. And 8 doesn't actually count because 8 gives us the y value of 0. So right here, and the rest of that graph is going to be positive forever. So from 8 up to infinity. Think we can handle that? Okay, let's graph the next one. So negative 6x plus 8. Is there a portion of this graph that's positive? Yes. Is there a portion of the graph that's negative? So we should have both. We should have a positive answer and a negative answer. Okay? Well, I need to know the root. I need to know the x-intercept. So we're going to use second calc, go down to 0, left bound 0, right bound 2, and my guess will be 1. And that answer is 1.33. So we know at 1.3 repeating, the graph switches from positive to negative. So what would the interval of all of the positive values be? So when is this positive? So positive x equals what is the smallest x value that will give me a positive number? What's that? 1.33 is the biggest. So here's the changing point. Are my positive values to the left of that or to the right of that? So I'm splitting the graph in half. Okay? And I'm just looking at the top half of the graph. Does the top half of the graph occur left of 1.3 or right of 1.3? To the left. So everything from here over is an x that gives me a positive y. So if I were to plug in -6, I would get some positive number way off the screen. Okay? So what is the interval of all x's that give me positive values? -infinity up to 1.3 repeating. I'm getting a lot of blank stares. Who does not understand that? Who does understand that? Let's do the other way. Okay? Half of you? So what we're trying to do is figure out, when does the graph occur above the x-axis? So we know, let me clear all that out. If I look at the top half of the graph, so that portion of the graph, if I were to trace that graph down to the x-axis, so from here down to the x-axis, okay, those x values are the numbers that give me positive values on the graph. So I have x values and I have y values. And I'm asking which x values give me positive y values. And to find those, I just go from the graph and go straight down to the x-axis. You want to close that door? So what I'm creating here is a portion of the x-axis. And all of these numbers are attached to the graph above the x-axis. Does that make more sense? So all we need to do is write down all of these numbers. So in this list, we need to find a number on the very right of it and a number to the very left. Well, the number on the left is -infinity. It never stops. So if I want a positive function, then x equals everything from -infinity all the way up to 1.3 repeating. Did that help at all? A little bit? Okay. We'll try the other side. So now let's look. Yes, your interval has to be from little to big. Whenever you write an interval, it has to be small to big, left to right, always. So on the other one, negative occurs when x equals, well, that's this part of the graph. So, well, from right here. If I trace those up, I create a group of x's, and in this group of x's, the smallest number is 1.3. The biggest number is infinity. So from here I can tell, if I plug in a number in that group, and that's called an interval, if I plug in a number in that interval, I know the answer will be above the x-axis. If I plug a number into the other interval, I know that the answer will be below the x-axis. Okay, let's try another one. And again, if you don't understand something, please ask me to stop and I'll try to explain it a different way. So x squared minus 4x plus 5. When is this graph above the x-axis? Always. When is it below the x-axis? Never. So the positive x's, well, the function is positive when x equals every real number. There are no negative answers in this case. There are negative x's, but when I plug in a negative x, like -1, the function value is a positive number. So this one is always positive, no matter what. Okay. We'll look at the next one. It's positive everywhere and it's negative nowhere. And you do need to write that negative version so I know you understand the negative side of things. Okay. The next one, negative x squared minus 10x minus 25. When is this graph positive? Never. When is it negative? Is it always negative? Well, this graph comes up, hits -5, and then goes back down. So at -5, is that graph negative? No, because 0 is not a negative number. So it's negative everywhere except x equals -5. There are two ways to write this. Well, of course, positive is the empty set. There are no positive values on this graph. For negative, how do you describe everything but -5? You can do it this way. X is every real number except for -5. Could we break it up into intervals? What would the intervals be? -infinity, comma, -5. So everything from here over. And the other side starts at -5 and goes out to infinity. Now, why does this exclude -5? Right, it's not a bracket. Brackets would include 5. But by using parentheses, we've thrown -5 out. Okay? So x squared minus 4x minus 18. Oops. So this graph is broken into 3 sections. 2 of those sections are positive, and 1 of those sections is negative. So if I were to draw this graph, it comes down through here, and it goes off the page, and then comes back up around there. So here is a positive version, and here is a positive version. And again, remember, we're not looking at going up and going down. We're just looking at above the x-axis and below the x-axis. And then this group down here is negative. So if I started with this section, which x values are going to make that negative? Or positive, sorry. So my positive version is x equals, I heard -infinity, all the way up to, I don't know. I need to find that value. So second calc, go down to 0. And I'm going to plug in left bound, say -4, -2. I'll pick -3 as my guess. So this value here is -2.69, which means that at -2.69, the graph all of a sudden becomes non-positive. What happens after that? What happens after -2.69? It becomes negative. How long does it stay negative? Until whatever's over on this side, so we need to find that root. So 1, 2, 3, 4, we can do 5, 8, and 7. 6.69. So if it's a quadratic, Nathan, you're going to get that, as long as each number is a whole number in the original function. So it's going to be negative from negative 2.69 all the way up to 6.69. And then it becomes positive. How long is it positive? From 6.69 all the way until infinity. Okay, I want you to start working on the rest of this. There are a couple more things that we need to learn, so I'll go over those when we get